Magnetosphere Evolution and Stellar Metamorphosis. This paper right here. It doesn't contain a lot of math, but the math will be worked on in the future. That's something that can wait. We have to get the basic principles down before we start working on math. If we start to do math before we have the basic principles, the math is just going to go off into oblivion and nothing is ever going to be explained properly. That's why these papers don't have a lot of math. I'll go ahead and read this out. In stellar metamorphosis, the oldest stars have lost the majority of their visible light spectrums. Therefore, to tell how internally active the star is, we can look at how strong the global magnetic field is. A big global magnetic field signals a star is less evolved than a star with a very small global magnetic field. This rule of thumb applies to stars' evolutionary path as they lose energy as they evolve, so their internal motion will diminish due to mass loss, friction, gravitational potential energy being converted to heat, etc. With regards to white dwarfs, which are the beginning of star evolution, their global magnetic fields are weakened significantly and outright lost as the star expands to its fullest blue giant size. After it expands to dissipate the heat of formation, it will then contract again, allowing for the reformation of a global magnetic field based on the newly formed different properties of the star. As well as the white dwarf's magnetic field needs to be worked on significantly. If you look at the graph here, you'll notice white dwarfs are at the beginning, go up, expand, and then they come all the way back down again, cool, and die and become what are called planets. To falsify this theory, we can look at brown dwarfs. This is very important. Those that say, a theory needs to be able to be falsified, well, this is a good way to falsify it. It is predicted that all brown dwarfs have newly generated extremely powerful global magnetic fields right after flare star stages, which are red dwarfs. If there are any brown dwarfs that do not have strong global magnetic fields, then the application of stellar metamorphosis to the evolution of stars is false. This being said, it is also predicted that brown dwarfs will have a very large aurora due to their global magnetic field sweeping in very large amounts of ionized material. This should also mean that they should be a strong source of radio waves. The intensity of the radio waves being emitted from brown dwarfs can be used to determine the size of the magnetic field, thus their stage of evolution. Bigger field, more stuff coming in, brighter aurora. It's that simple. And here's a conclusion of this. In stellar metamorphosis, the young population 1 stars are mostly plasma and stars in the visible light spectrum. The more advanced stages of population 2, which are mostly gaseous matter and no longer have strong visible light spectrums. Population 3 are solid and liquid material, and population 4 are dead stars. Concerning the magnetosphere evolution of stars, it is only population 1 to 3 that can have magnetic fields permeating the interior and the surface, as dead stars have no large-scale fluid motion to produce the fields. The internal fluid motion is what produces the fields. This being said, we can tell if a star is dead by seeing if it has a magnetic field. No magnetic field equals a dead star. This, of course, is very different than what establishment accepts. As to them, an extremely energetic star, such as a white dwarf, has a huge magnetic field and a high flux density at that, yet they are dead, which should make the reader question their theories. How does something that is supposed to be dead have so much energy? At least 10% of white dwarfs found have a surface magnetic field strength of at least 1 million Gauss, or 100 Tesla. This further supports stellar metamorphosis, as white dwarfs are placed firmly at the beginning of stellar evolution, not the end. With objects that energetic, there is no way they should be considered dead. That would be like the author dying and then turning into a sustained 1,000 meter long lightning bolt. The reader should look up Dragon Ball Z, when Goku goes Super Saiyan. After I die, can you imagine that? That's what their theory says. They say white dwarfs are dead stars, yet they're incredibly energetic and they have very, very powerful magnetic fields. Dead stars do not have really strong sustained global magnetic fields. And that basically sums it up. I won't read this whole thing off, but yeah, it's a very simple thing to understand, and it's also very, very different than what establishment accepts as stellar evolution. They're lost in the sauce. You don't have to really look at their articles anymore. You can just sort of figure it out on your own now if you want. It's disappointing that something that's obvious is continually escaping them, even though it's the 21st century. Alright, y'all, take it easy.